Okay, 3.5% change and percent error. All right, so be careful in this section. The formulas really help out a lot. You got to be aware of the formulas on these. If you remember from last year, we have done percent change before. The triangle is delta, which means change in. So change in percent, you can do percent delta. You can just write percent change if you want, knock yourself out, but that's all the triangle means is change in. What's ugly? They got to get rid of that, so ugly. All right, so the triangle just means change in. And if you remember, you got to do the amount of change. The amount of change. And I'm going to write in green on the bottom what you divide by. Anybody remember what we divide by? Somebody raise your hand. Divide by. Anybody remember from last year? Divide by the original amount. And then the 100 is 100%. So the amount of change divided by the original amount times 100%, so you can get it into a percent. Percent change. Okay, so let's do a problem like A. Find the percent change from 3 to 4. Pretty simplistic. So our change in percent is just going to be a 4 minus 3. But you got to divide by the 3. You can't divide by the 4. We went from 3 to 4. That 3's got to be on the bottom. Multiply times 100% and you'll be there. But this one you can do in your head, right? Because we don't know what 1/3 is. So the change in percent is going to be 33.3. Might as well use the bar. 33.3%, right? So pretty simplistic problem if you know the formula, right? If you know the formula. If you don't know the formula, then it becomes a little bit more interesting, a little bit more tricky. So B, find the percent change from 4 to 3. 33%, right? 4 to 3. We just did 3 to 4. 4 to 3's got to be the same thing. And the answer is no, right? Go ahead and run the formula. Run the numbers. What's the percent change from 4 to 3? I will say that some like to use positive and negative numbers to use a negative number to say that you went down and a positive to where you went up. So if you, in that respect, you would do a 3 minus 4. Went from 4 to 3. It's usually final minus initial. The second number minus the first. In which case you get a negative 25%. But others just say, oh, we're looking at the percent change and the change was 25%. So you just have to be careful. If you're doing a homework problem, just pay attention to what the directions are asking you for. So some would want you to go ahead and do positive and negative, positive percent for a percent increase, negative percent for a percent decrease. This one obviously went down, right? 4, 2, 3. So it was a 25% decrease was the change in percent. Again, you can do that mathematically. If you do 3 minus 4 and divide by the 4, you'll end up with a negative 25%. Okay? Notice it's different. That's why some miss the concept of this. Let's suppose your parents own stock in Microsoft. And Microsoft went down 20%. Ooh, big drop. Big drop. And then the next day it went back up 20%. Are they right back to even? Are they even Stevens? And the answer is no, because 20% of a bigger number is more than 20% of a smaller number, right? They had more and lost 20%. Now the number's smaller. So 20% of that smaller number is not going to get you all the way back up to where you were. So actually, they lost, even though the percents were the same. You just got to be aware of that. Okay, let's do C here. An iPhone 6 sold for $499 and later sold for $449. What was the percent change? All right, and obviously this is a percent decrease. Go ahead and run that one. What is the percent change? So I'll do this one with the negative, but you don't have to. Does the mams like your answer? Really, what we're asking here is $50 is what percent of 499, right? Is what we're asking. And the answer is 10%. If you round off, you get 10.0. And again, if you use the positive and negative, you'd get negative 10.0%. Again, some would just say, hey, say 10%, that's the percent change. Others would say, do negative for a decrease and positive for an increase. I'm showing it to you both ways because you should just be aware that either way is possible. If I don't specify, I would take it either way. Okay. We'll deal with signifying the percent change in a little bit different kind of problem later on. Any questions on that so far? Percent change? So obviously the key is remembering the formula, right? I mean, if I don't give you the formula, you got to remember it. So therefore, whenever we do homework to help you remember formulas, what do I always want you to do with your homework? Write the formula each time. Ethan, did you catch that? So each time you do a problem, write the formula again first before you sub into the formula. It's just going to help you try to remember it. And remember, we're only going to do so many problems, so it's not like we're doing 100 of them. I'm just trying to help you to remember the formula. Okay. For percent increase and percent decrease. So that's percent change. Percent increase and percent decrease. All right, so remember the main formula. The number equals the percent times the of number, right? I mean, that's still true. The part equals the percent times the whole, right? Still got that. To change the problem from a two-part problem to a one-part problem, you can do what I'm going to show you here. So you can do these problems in 2 steps, 2 parts, or you can do them in one. I like to do them in one, and to do them in one, it's this simple concept. For an increase, use 100% plus the percent increase for the percent. And what do I mean for the percent? For the percent in the problem of the number equals percent times the of number. So for example, let's suppose we have a 20% increase. So now you're doing 100% plus 20%. And therefore, in the percent, you're going to use 120%. So in the formula, how would you write 120%? Somebody raise their hand and tell me, how would you write 120% in the formula, John? 1.2, right, or 1.20. So remember, your percents are always in decimal form in the formulas. So by doing 120%, it's a one-step problem. Now, again, you can do it in two steps. You can first figure out 20% of the amount, then take your answer and add it to the original amount. That's now we're going to figure out what 120% is. Or you can do it in one step, just like that. And we'll do examples here in a minute. Well, percent decrease, obviously it's going to be 100% minus the percent decrease. The down arrow just represents decrease. And again, that's going to go in for the percent. So if we want to figure out something after a 20% decrease, we're going to do 100% minus 20% for a total of 80%. At which case we'll simply put in 0.8 for the percent and do it in a one-step situation. Again, you can do it in two steps, but it's so much easier just to do it in one. You're cutting out calculations, you're saving time, and those issues are important. Raquel? The formula will only work when the percents are in decimal form. If not, the numbers don't work. It's really because our number system is based upon base 10, and also because a percent with the percent symbol doesn't equate. It has to be a number. You're going to see that in a minute. We're going to do a couple problems here, and you'll see exactly the point of it all. Okay, so let's do a problem here, C. Let me get a little bit more room. What is 110 increased by 8%? 110 increased by 8%. So hopefully you would agree that the percent implies 108%. Right? The original 100% plus 8% more. Does that make sense? 108%. So now we're just to the formula. Number equals percent times the of number. And again, if you like part equals percent times the whole, go ahead, that's fine. What is 110 increased by 8%? So on this one, you are looking for the number. Our percent is 1.08. And we're going to multiply the of number on this one is 110, though it's not as obvious. So it's straight calculator, right? Grab your calculator out, punch it out, and then ask the mams. Does my answer make sense? 1.08 times 110. 1,118.8. 118.8. Good, you were listening. Not that I did that on purpose. 118.8. So is that about roughly an 8% increase from 110? That sounds reasonable. 10% increase would be 11, right? 11 more. So you'd be at 121. 8%, a little bit less. 118.8 sounds good. So that's a one-step procedure. Here's what some of you will do. What's 8% of 110? You're going to get 8.8. Excuse me. Then you're going to have to add that 8.8 to the original number of 110 to finally end up with the answer of 118.8. Because we want to increase that 110 by 8%. Feel free to do it in two steps if that's what you feel more comfortable with. But just remember, time issues are issues in mathematics, especially when it comes to taking tests. So the more efficient way does have its advantages. Okay, so the second example here, D. Now you got money, 77 decreased by 10%. So again, in this one, right, decreased, our percent is going to be 100% minus 10%. So this is going to be 90% for our percent, right? If we want to do it in one step. And again, number equals percent times the of number, or part equals percent times the whole. None of those may make you feel comfortable, but the reality is you're solving for the number in these. All right, hopefully you all agree the percent is going to be then 0.9. And the of number is the $77. I'm going to leave my dollar symbol in my math so that I remember to finish with the dollar symbol. So calculator, ask the mams. Byron, how much you got? Does the mams like that answer? Does she $77 decrease by 10%? All right, good. The mams doesn't like that answer. So think about it. Think about what maybe you did wrong. Ashton? 69.3. Does the mams like that answer? The mams is starting to like that answer. And is your amount sound good as well, Ashton? Right? 10% decrease from 77. 10% is easy. That's going to be 7.7. Sure enough, $69.30. So, Byron, I'm not sure what you multiply. Maybe by 9? You did E? Oh, okay. We'll get there in a minute. We'll see about that smartphone. All right. Any questions on D? All right. Why don't you all do E while he does D? All right. And I'm going to pause. We're in $284.25. All of you correct ones, right? Because if you're going to do it in one step, 25% sale is going to give you a 25% decrease. Therefore, you need 75% of the amount. DeMams likes that answer, and we're rolling on to the next one. Any questions on that? How many got that right? Okay, just about everybody. Those aren't hard if you remember that aspect. All right, let's keep rolling here. Number 3. And I wish I still had my shade, but try to just focus here on 3. Experimental error. Experimental error. What is it? It's the experimental value minus the known value. Experimental error minus the known value. And in this, the error can be positive or the error can be negative. You can have a positive error or a negative error. So let's look at example B here. Dr. Wee calculated the mass of 1 cc of pure gold to be 19.1 grams if the accepted value is 19.3 grams per cc. What is the experimental error? Okay, that's not really hard at all if you just look at what we're dealing with. So experimental error, I'll go EE. What was his experimental value? What did he calculate? 19.1 grams. And how many cc's did he have? How many cc's did he have? 1, right? So he got 19.1 grams per cc. It's the only tricky part to the whole problem. Now the formula says minus, whoops, should have been red, minus the known value. And the problem told us known value. What if you didn't know the known value? Where are you going to get it? Where I got this known value from. Guess where I got the known value from when I made up the question? I looked it up on the internet, Google it or Bing it or whatever, all right? And so 19.3 grams per cc. cc is a cubic centimeter. And therefore then just run those numbers. And our answer is going to be a negative 0.2 grams per cc is the experimental error. It's just how much is he off from the known value. That's all experimental error is. Okay, there's a known value for something. When you did it by experimentation, you didn't get the known value. Okay, how far off are you? That's all it is. Don't get all scared and weirded out by it. There's a known value. You calculated something a little bit different. Okay, how far are you off? Are you above it? If you're above it, you got a positive experimental error. Are you below the known value? You got a negative experimental value. Not too bad. Now, what about percent error? Percent error. Well, here you got to do the absolute value. So this one, we're not worried about positive or negative. The absolute value of the experimental value minus the known value. Hey, you know what that's called? What's the experimental value minus the known value called? Experimental error. So we could say the top is the absolute value of the experimental error, right? Because that's what value minus known is. And then you have to divide by the known value. Multiply by 100%. This goes along with the percent change formula in that aspect. It's just the bottom, not the original number, the known value. So experimental error divided by the known value times 100%. All right, so I got another example here. The mass of oxygen is 16 grams per mole. Tim found it to be 16.15 grams by experimentation. What is the experimental error and the percent error? All right, so 2 questions, right? And we got to kick it into a little bit higher gear here. So let's get rolling. Let's do it all within the one formula. Percent error is the absolute value. Somebody tell me what to put in for the experimental value. 16.15 what's? Keep the units, keep the units, keep the units. Formula has a minus. Known value, they said, was 16 grams. We're taking the absolute value. Which one are we dividing by? Say it if you know it. 16 grams. And then don't forget times 100%. Okay. Before I go too far, let's figure out the experimental error. So on that one, we are worried about positive and negative. So what's the experimental error? Somebody raise your hand, tell me the experimental error. Andrew? You're too far ahead. All I'm looking for right now is the experimental error. Kirsten? 0.15 grams is the experimental error. I was just looking for the numerator right now, Andrew, without the absolute value, right? Because that's the experimental error. Then when you run all the numbers, Andrew, what do we get for an experimental error? No. Nope. Anybody else? So again, just run it, 0.15 divided by 16, and then times 100. Percent errors should not be very much. Okay, then what do you got? And that is percent, 0.9375%. Percent error should not be very big. 0.9375%. 0.9375%. Just punch it in your calculator. Now, just let me make a quick note. This time the experimental error was positive, so the absolute value didn't matter. But if it would have been negative, we would only consider the positive value. Because listen, percent error is always just positive. That's why the absolute value. All right, what do I have left? All right, let's get to this. Percent difference. That should have been black. Percent difference indicates how much as a percent two experimental values differ. Percent difference. I gave you most of this formula already. Percent difference. First value minus second value. You're doing an experiment. You get two different values, right? You run it. You guys have all done science fair. You get the same number every time you run something on a science fair? You don't. So the first time you get a value, the second time you get a value. Now we're going to do absolute value. Positive and negative doesn't matter. We're going to divide by the average of the two values times 100%. And that'll give you a percent difference between your two experimental values. Okay. So first value minus second, divided by the average of the two values, and that will then give you a percent difference between those two values. And I don't think we have enough time, so I'll give you the answer if you want to work this on your own. This thing ends up being, if I can read my own handwriting, I think it's 6.16%. Would be the difference if you were one time to get a 17.3 grams per milliliter value and a second time 18.4 grams per milliliter value. All right, don't forget, 9th graders, PSAT tomorrow. You will not take the quiz. 8th graders, you will take the quiz tomorrow. And everyone else, 9th graders, homework on my desk before you go to the PSAT.